Quality attributes are non-functional requirements that need to be documented properly in any system design. If the quality attributes are more concrete and measurable, it will give you positive impact on the system development process and the end product. The various quality attributes that need to be addressed in any embedded system development are broadly classified into two: operational quality attributes, non-operational quality attributes. Operational quality attributes represent the relevant quality attributes related to embedded system when it is in the operational mode or online mode. The important quality attributes coming under this category are response, throughput, reliability, maintainability, security, and safety. Response. Response is a measure of quickness of a system. Very important here is quickness of the system. It gives us an idea about how fast our system is tracking the changes in the input variable. For an example, as soon as I apply the brake in an automobile, the automobile should stop. So here the application of the brake is an input. For that, my vehicle should stop. That is a response. Okay. Most of the embedded system demands fast response, which should be almost real time. So most of the embedded system gives a fast response. For example, an embedded system deployed in flight control application should respond in real-time manner. In a flight-controlled system, there may be a small embedded system, there may be some embedded system which should respond quickly. Any response delay in the system means a delay in the response will create potential damages to the safety of the flight as well as the passengers. It is not necessary that all embedded systems should be real time in response. There are some embedded systems where a small amount of delay may not harm much. Such an embedded system is also existing. For example, response time requirement for an electronic toy is not at all time critical. There is no specific deadline that this system should respond within this particular timeline. Throughput. Throughput deals with efficiency of a system. Throughput deals with efficiency of a system. In general, it can be defined as rate of production or operation of defined process over stated period of time. The rate can be expressed in terms of units of products, batches produced, or any other meaningful measurements. In the case of a card reader, throughput means how many transactions the reader can perform in a minute or in an hour or in a day. Another example, in a printer, how many printouts it can take, it can print per minutes. In terms of copier machines, in the case of copier machines, how many copy of a document it can take per an hour, that defines about the throughput of that machine. Throughput is generally measured in terms of benchmark. Building better product requires good comparative perspective about other companies to gain insight into other sources of outstanding performance. Repeat, building better product requires good comparative perspective about other companies to gain insight into other sources of outstanding performance. A benchmark is a reference point by which something can be measured. Benchmark is a reference point by which something can be measured. Benchmark can be a set of performance criteria that a product is expected to meet, or a standard product that can be used for comparing other products of the same product line. Benchmark can be a set of performance criteria that a product is expected to meet, or a standard product that can be used for comparing other products of the same product line. Another definition for benchmarking. Benchmarking is the continuous process of measuring products, services, and practices against the toughest competitors or those recognized as industry leaders. For an example, when a Samsung company, if it is releasing a mobile, it is going to compare its internal RAM, ROM, or battery backup and camera resolution with other company which is already existing in an industry and which is a leader in the which is a market leader. Benchmarking requires good detective and research skills, product design, cost estimating, design for assembly and manufacturability. Another attribute is a reliability. Reliability is a measure of how much percentage you can rely upon the proper functioning of the system, or what is the percentage of susceptibility of the system to failures. Reliability is measure of how much percentage you can rely upon the proper functioning of the system. See, there's one trend in a market. If it is made in Japan, people will buy easily because people are having a good opinion about the reliability of such materials. So terms used in defining system reliability: mean time between failures, time gap between failures, mean time to repair. These are two terms we are using to define a reliability. Mean time between failure gives the frequency of failures in hours or weeks or months. So in a month, how many times it may fail? For an example, when you buy a copier machine, that person will ask, so how many times it may fail or fail in a month, because that is also very important. MTTR, mean time to repair, specifies how long the system is allocated to be out of order following the failure. Sometimes some system will work even if some small changes happens in its working style also. We can continue to work, use it before we repair. For an embedded system with critical application, it should be of the order of minutes. Both should be MTBF and MTTR should be order of minutes. Maintainability. Maintainability deals with support and maintenance to the end user. Maintainability deals with support and maintenance to the end user or client in case of a technical issues and product failures, or on the basis of a routine system checkup. When a shopkeeper buys a copier machine, he is worried about maintainability. So because as an end user, he expects maintainability. So reliability and maintainability are considered as two complementary disciplines. A more reliable system means a system with less corrective maintainability requirements, and vice versa. A more reliable system means a system with less corrective maintainability requirements. So maintainability requirement is very less if a system is more reliable, and vice versa. As the reliability of the system increases, the chances of the failure and non-functioning also reduces. The chances of failure and non-functioning also reduces. As the reliability of the system increases, the chances of the failure and non-functioning also reduces. Thereby, the need for maintainability is also reduced. The maintainability is closely related to system availability. Maintainability can be broadly classified into two categories, namely scheduled or periodic maintenance. This is a preventive maintenance because each month we will do some systems requires yearly maintenance, or some system requires 6 month maintenance per 6 months. And maintenance to unexpected failure, corrective maintenance. As soon as if some changes happens in this function, people will go for maintenance. Some embedded products may use consumable components or may contain components which are subject to wear and tear, and they should be replaced on periodic basis. Some embedded products may use consumable components. Some embedded products may use consumable components or may contain components which are subject to wear and tear, and they should be replaced on a periodic basis. This is also common sometimes. The period may be based on the total hours of the system usage or total output system delivered. An inkjet printer uses ink cartridges which are consumable components, and as per the printer manufacturer, the end user should replace the cartridge after each n number of printouts to get a quality prints. This is an example for a scheduled or a periodic maintenance. The paper feeding part of the printer fails. The printer fails to print and it requires immediate repairs to rectify this problem. This is an example of maintenance to unexpected failure. In both of the maintenances, scheduled and repair, the printer needs to be brought offline, and during this time it will not be available for the user. It will not be available for the user. So hence it is obvious that maintainability is simply an indication of the availability of the product for the use. Maintainability is simply an indication of the availability of the product for use. To an embedded system design, the ideal value for an availability is expressed where A is availability in the ideal condition, MTBF, mean time between failures, MTTR, mean time to repair. EI, availability in the ideal condition is MTBF into MTBF plus MTTR. Security. Confidentiality, integrity, and availability are the three major measures of information security. Confidentiality, integrity, and availability are three major measures of information security. Confidentiality deals with protection of data and application from unauthorized disclosures. Nowadays, most of the embedded system we are here, like handheld devices, mobiles, or any handheld computer systems are where even data are very important. Okay, sometimes we are using some of the applications also. Integrity deals with protection of data and application from unauthorized modification. Unauthorized modification. Availability deals with protection of data and application from unauthorized uses. A very good example of security aspect in an embedded product is personal digital assistant. The PDA can be either a shared resource or an individual one. Assume like this. So we are having one PDA. Several people are using it. If it is shared one, there should be some mechanism in the form of username and password to access into particular person's profile. This is an example of availability. So each one will keep one username and password so that each one can access to his profiles. That is an example for availability. Also, all data and application present in the PDA need not be accessible to all users. Some of them are specifically accessible to administrators only. In that cases, for achieving this, administrator and user levels of security should be implemented. An example of confidentiality. So that administrator only have a right to access his data. Some data present in the PDA may be visible to all users, but there may not be necessary permission to alter the data by the users. So user can see it, but he cannot alter it. That is the read-only access is allocated to all users. An example of integrity. So integrity, this is one example. That's meaning of integrity. So another attributes is safety. Safety and security are two confusing terms, but they represent two unique aspects in the quality attributes. What is safety? Safety deals with possible damages that can happen to the operators, public and environment due to breakdown of an embedded system or due to emission of radioactive or hazardous materials from the embedded products. So I'll repeat, safety deals with the possible damages that can happen to the operators, public and environment due to the breakdown of the embedded system or due to the emission of radioactive or hazardous materials from the embedded products. One example is if a mobile explodes. So what are the what happens? That is called as a safety. So if mobile explodes, or else in a 5G system, what are the what is the problem caused by the radiation of the 5G mobile? That is also one of the safety issues. The breakdown of an embedded system may occur due to hardware failure or a firmware failure. The breakdown of an embedded system may occur due to hardware failure or firmware failure. Yeah, sometimes if there is a problem in battery, or if there is a problems in the circuit, or else if there is a problems in this software also, system may break down. Safety analysis is a must in product engineering to evaluate the anticipated damages and determine the best course of action to bring down the consequences of the damage to acceptable level. For an example, in a 5G mobile, there is an issue called radioactive radiation problem due to radiations. So it's duty of a company to minimize that radiation effect. Okay. As stated before, some of the safety threats are sudden and some of them are gradual. Like product breakdown, this is a sudden. Like hazardous emission from the product, this is a gradual. So many devices are causing some hazardous emissions, and some products is very it will cause some problems to environment during disposal also. All those things should be considered. The quality attributes. So next is non-operational quality attributes. The quality attributes that needs to be addressed for the product not on the basis of operational aspects are grouped under this category. The important quality attributes coming under this category are listed below. One is testability and debuggability, evolvability, portability, time to prototype and market, per unit and total cost. All are related to development procedures. So when we are developing any system, so these issues will come into picture. Testability and debuggability. Testability deals with how easily one can test his or her design applications, by which means she can test it. For an embedded product, testability is applicable to both embedded hardware and firmware. See, when you develop a system, we should test. We should test our design, we should test our final applications. Then only we will realize the faults and corrections. Everything we can find out. So debugging is once you write a software, or when you connect all the input devices and output devices and sensors, we should test our total system to check whether our system is functioning as per our expectation or not, and how my system responds to changes in the environments, or to how my system responds to the events. All these things we should we will come to know only if we debug the system. Debugging is simply, we can say that, to checking the correctness of the functions of that system. Embedded hardware testing ensure that the peripherals and total hardware functions are in the designed manner. So initially, when you write a software, you can simulate it, and once simulation is working fine, you can transfer that program to the memories of the processors. You can connect all the sensors, and you can assemble that in the embedded part in the main system. If it is a vehicle, if it is electronics control unit, assemble in vehicle, then again test it. So several stages of testing is also existing. Firmware testing ensure that firmware is functioning in the expected way. This is only testing the software part of your embedded system. So for these kinds you can use simulators. Debuggability is a means of debugging the product as such, for figuring out the probable sources that create unexpected behavior in the total system. Unexpected behavior in the total systems. Yeah, when you develop a systems, unless we debug it, we will not be able to find out the errors, or we will not be able to find out unexpected behaviors. Debuggability has two aspects in the embedded system development context, namely hardware level debugging and firmware level debugging. First we will do, or sometimes parallelly also they will do it. One is software, we should debug it properly, and hardware also we should debug it. If there is any problem, circuits problems, if it is any problems in the sensors, everything we should correct it after debugging. Hardware debugging is used for figuring out the issues created by hardware problems, whereas firmware debugging is employed to figuring out the problems that appears as a result of flaws in the firmware. If there is a flaws in the firmware, we can rectify after debugging this software. Evolvability. This is very important. Evolvability is a term which is closely related to biology. Evolvability is referred to as a non-heritable variation. Is referred to as non-heritable variation. For an embedded system, the quality attributes. So, evolvability referred to as ease with which embedded product, including firmware and hardware, can be modified to take the advantages of new firmware or hardware technologies. Most of the times we will develop one systems, and yearly software also changes, hardware, like new processors will come, and people will do changes in the new processors will come. So each processor will have a new instruction set and all. For that processor, maybe new compiler might have developed. Sometimes we need to transfer, or we need to change the softwares whatever is already developed to a new processes. It should work in a new environment. That's the reason. So small changes may be required. So when we are developing a software or a system, we should consider evolvability. If my system is having is able to it is have consisting evaluability property, then the coming years also my system will be existing, but at the same time it is running in maybe in a new processes and in a new environment. So one examples I can tell you, this is very common in embedded systems. For an example, what are in olden days, what are the software they have developed in for 8085, and everything they transferred to 8086. So most of the system which was developed initially for 8085, it worked fine well in 8086 also. Later again most of that are changed to Pentium series processor and all. Portability. Portability is a measure of a system independence. Portability is a measure of system independence. This is also an embedded product is said to be portable if the product is capable of functioning as such in various environments, target processes, controllers, and embedded operating systems. An embedded product is said to be portable if the product is capable of functioning as such in various environments, target, processor, controllers, and embedded operating systems. For an example, target processor, maybe you are developing is one embedded system which works for STM32. Tomorrow the same system we may want to shift to another processor. It may be a Raspberry Pi. So in such cases our software or our system should have an ability to port. Means if it is easily portable, then it is a very good property. Repeat it. An embedded product is said to be portable if the product is capable of functioning as such in various environments like target processor, mainly in different target processor, and embedded operating system. Yeah, this is also very important. There are several operating systems we use in your embedded system also. If I am developing one applications to run in one operating system, if it is working fine in another also, then it is a one good advantage. The ease with which an embedded product can be ported on new platform is a direct measure of rework required. The standard embedded product should always be flexible and portable, so that if I develop some system with STM32, if I can transfer all my hardware, peripherals and software to another ARM based processes, then I can say that my system is easily portable. Or else in embedded products, the term porting represents the migration of the embedded firmware written for one target processor to a different target processor. Like if it is developed for Intel 86 based processors, if you are transferring to Hitachi SS3 processors, then if it is transferable, then I can say that it is having a very good portable property. The firmware is written in high level languages like C with a little target processor specific functions. It is very easy to port the firmware for new processors and recompiling the program for a new target processor specific settings. The firmware is written in high-level languages like C with a little target processor specific function. So when you are developing this function program with C-like high-level languages, these target-related functions are very little. Operating system extension or compiler specific utility with little target processor specific functions. It is very easy to port the firmware for the new processor and recompiling the program for new target processor specific settings. Sometimes most of the time, we'll change the header files and we'll do that. Recompiling the program for a new target processor generates new target processor specific machine codes. For an example, if I've developed a software using our Intel processors based Intel based microcontroller, and seems with a little modification, I can change that, I can generate a machine codes for the same software for the ARM microcontroller also. If the firmware is written in assembly language for a particular family of processor, it will be very difficult to translate the assembly language instruction to the new target processor specific language, and so portability is very poor. Yeah. Assembly languages is where instructions are directly connected to that particular processor architecture and registers available, so that portability is a little difficult if you are written all these softwares in assembly language. If you look into various programming languages for application development for desktop applications, you'll see that certain applications developed on these certain languages run only on specific operating system. Some of them run independent of desktop operating systems. If you look into various programming languages for application development for desktop applications, you'll see that certain applications developed on certain languages run only on specific operating systems. Some of them run independent of desktop operating systems. There are several desktop operating systems: Linux, Unix, Windows. For example, applications developed using Microsoft technologies, Microsoft Visual C++ using Visual Studio is capable of running only Microsoft platforms and will not function on other operating systems. Whereas application developed using Java from Sun Microsystem works on any operating system that supports Java standards. Time, this is also a very important property: time to prototype and market. Time to market is the time elapsed between the conceptualization of the product and the time at which product is ready for selling, for commercial product or use. For an example, when you have an idea about a product, first of all, that concept should come, and we should develop a prototype for that. Then later we should commercialize it. It will take a lot or some amount of time. So how much time it takes, that depends upon, that is defined by time to prototype and market. The commercial embedded product market is highly competitive, and time to market the product is critical factor in the success of commercial embedded product. So any commercial embedded product, if you take a little time to prototype and for marketing, to make it ready for market, so then there is a higher chance of success. There may be multiple players in the embedded industry who develop products of the same category, like mobile phones, portable player, etc. If we come up with new design, if it takes a long time to develop and market it, the competitor product may take advantages of it with their product. This is true. So as we should not lagging behind the other company in developing a product. Also, embedded technology is one where rapid technology change is happening. So technology is also here changing rapidly. If we start our design by making use of a new technology, and if it takes a long time to develop and market the product, by the time we market the product, the technology might have superseded with the new technology. Sometimes, like see, in a TV, LCD has come, later LED has come. So like this, technology will changes. So if it takes a long time to develop and market the product, by the time we market the product, the technology might have superseded with the new technology. Product prototyping helps a lot in reducing time to market. So it is better to do a prototype of a product as soon as possible. Whenever you have a product idea, you may not be certain about the feasibility of the idea. Prototyping is an informal kind of rapid product development in which important features of the product under consideration are developed. Yeah, prototyping need not consist everything, every functionality of the product. Some main part of the product we need to develop as a prototype. The time to prototype is also another critical factor. If a prototype is developed faster, the actual estimated time can be brought down significantly. The prototype is developed faster, the actual estimated development time can be brought down significantly. In order to shorten the time to prototype, make use of all possible options like use of off-shelf components, reusable assets, etc. Per unit cost and revenue. Cost is a factor which is closely monitored by the both end user, those who buy the product, and product manufacturer, those who build the product. Cost is highly sensitive factor for commercial products. Any failure to position the cost of a commercial product at nominal rate may lead to failure of the product in the market. So we should release a product at a nominal rate, a particular embedded industry, then only we can survive. Proper market study and cost benefit analysis should be carried out before taking a decision on the per unit cost of the embedded product. Proper market study and cost benefit analysis should be carried out because to take a decision on the per unit cost of the embedded product. So per unit cost of an embedded product should not exceed the per unit cost of some other product because otherwise we will fail. From designer product development company perspective, the ultimate aim of the product is to generate marginal profit. This is very important, to generate marginal profit. So the budget and total system cost should be properly balanced to provide marginal profit. Per unit cost and revenue. Every embedded product has a product life cycle which starts with design and development phase. Every embedded product has a product life cycle which starts with design and development phase. We will call as a design stage, and then next second stage is a development phase. The product idea generation, first idea should come up, and prototyping, then roadmap definition, actual product design, development are the activities carried out during this phase. During the design and development phase, there is an investment and no returns. Yeah, this is very important. During the design and development phase, there is an investment and no returns. See, this is a graph. It is showing about time and revenue. Listen here, when any product comes into a market, initially its sale is very less, because as soon as when one mobile is released, very few people were using a mobile. This is the case in 2099 and all 2000. Very few people used mobiles. Later, mobile market increased like this, increased like this. Nowadays, we are in some area like this. Huge market has built for the mobile, and later after some times, people will not. This product also will die. So market for that product will reduce. That's the reasons. If you release a product somewhere here, you need to wait for some more time to get a benefit. To release somewhere here, we will get a lot of benefits. If you release a product here, definitely we will lose the revenue. Our company will lose the money. So better. So this is a very important point. So every system, it may be a mobile, it may be a TV, it may be any product, or it is applicable for new technology. For example, LCD technologies, time is over now. Somewhere we are in now. LED has come. So this is applicable for all new technology and as well as for new system. It's very good, very important curve here. This we need to remember when we are starting a new venture or when you are releasing a new business. We need to understand where we are, whether we are in this stage, or this stage, whether it is the right time to start our product or not. That we need to decide. That unit cost, profit. See, if you release a product somewhere here, profit may be less. The profit is very high somewhere here. And if you are releasing in these falling edges, if you are releasing a product somewhere here, the profit will reduce. This is product development, product introduction, growth, product maturity, product retirement. Once the product is ready to sell, it is introduced to the market. Once the product is ready to sell, it is introduced to the market. This stage is known as a product introduction stage. During the initial period, the sales and revenue will be low. There won't be a much competition, and product sales and revenue increases with the time. There won't be a much competition, and product sales and revenue increases with the time. After some time, revenue will increase. In the growth phase, the product grabs high market share. So this is somewhere here in this growth stage. During the maturity phase, the growth and sales will be steady and revenue reaches its peak. This is somewhere here, this period. During the product retirement decline phase starts with a drop in sales volume, market share and revenue. The decline happens due to various reasons like competition from similar product with enhanced features or technology changes, etc. Decline happens due to various reasons, like competition from similar products with enhanced features and technology changes. Because, for an example, a olden TV, it is people are not buying. Even now, LED, people are buying LED TV. So LCD TV time is also over now. So when technology changes, product will lose the market. At some point of decline stage, the manufacturer announces discontinuity of the product. At some point of the decline stage, manufacturer announces discontinuity of the product. From the graph, it is clear that total revenue increases from the product introduction stage to the product maturity stage. Revenue increases from the product introduction stage to maturity stage. The unit cost is very high during introductory stage because the NRI cost is high. NRI cost is non-recoverable investment. Means, so whenever a company is producing a new product, you should do a lot of investment in research and development. So that money should be equally divided to the product, and one is a NRI cost, another one is per product cost, means how much money is required to make a duplicate of each copy of product. So unit cost is very high during introduction stage. The typical example is a cell phone. If you buy a new model of a cell phone during its launch time, the price will be very high. You will get a same model with a very reduced price after 3 or 4 months of the launching. The profit increases when the increase in sales and attains steady value, then falls with a dip in sales. We can see negative value of profit during the initial period. It is because during the product development phase, there is only an investment, no returns. Profit occurs only when the total returns exceed the investment and operating cost. Thank you.